Welcome, everybody. This is the Virtual Residency Workshop 2026. It is our final day, Friday, June 26th, 2026. And this is the first session of the day. This is a panel on emerging technologies. Our moderator is Michael Martin from the University of Central Oklahoma. So I'm going to turn it over to Michael to introduce the panelists. Go ahead, Michael.
All right. Thank you, Henry. The way we're going to set this up this morning, before I introduce the panel or have the panel introduce themselves, we're going to have each of the panelists take about 5 minutes and introduce themselves, give a little bit of background, and talk about a very specific technology, emerging technology that either they're working with or particular interest in. We're going to let each of the panelists have their moment there, and then when all the panelists are done, we're going to go ahead and start taking questions from everybody, and you can direct your questions to either any panelists that you have a question about the emerging technology that you would like for them to address. So, without any further pause, we will get started. We're going to start out this morning with David Lockett. David, welcome.
Hey, good morning. Thank you. My name is David Lockett. I serve as a grants development specialist and co-principal investigator at the School of Applied Computational Sciences at Meharry Medical College. We're the fifth new school at the university. Our main focus is data science, biomedical data science, AI, cybersecurity, and computer science. We host master's and PhD level students at the university. I am joined today by one of our student interns in the NSF-funded MSCC, and I'd like to pass it over to Kelvin Johnson Jr.
Greetings, everyone. My name is Kelvin Johnson Jr. I am a health science major at Tuskegee University and a 2026 MSCC undergraduate summer research intern. And today I will be discussing emerging technology. Emerging technology with a focus on blockchain. Do I go straight ahead?
Absolutely.
Okay. And I just share my screen, correct?
Yes, sir.
All right. Can everyone see?
We can see it.
All right. So blockchain, which is more than just cryptocurrency. It is a secure and transport ways to secure and verify information across multiple computers. As this technology is important because it is being used across industries like healthcare, finance, education, cybersecurity, and improved trust, security, and data accuracy. I have my next slide. So what is blockchain? Blockchain is a secure digital system that stores information across many computers. Instead of just one, it would make it difficult to change, hack, or delete records. Everyone in the network is able to verify new information accurate before it is added, which is creating a shared and trusted record. Once this information is approved and stored, it becomes permanent and cannot easily be changed because no single person or organization can control the data. Everyone will be able to work together to keep it secure and accurate. But blockchain also is able to improve security, transparency, and trust in areas such as healthcare, finance, supply chains, and cybersecurity. And why is blockchain important? So I'll be piggybacking on what it is as well. So blockchain is also like a secure way of storing and sharing information without depending on one central person or organization to control it. But instead, the data was spread across many computers, and the network works together to verify that the information is correct before it is added. And once it is recorded, it is very hard to change or remove, which will ensure information to stay reliable and trustworthy. And I think this improves security, reduces fraud, and increases transparency, which allows individuals and organizations to confidently share and use data. But as a result, blockchain is becoming increasingly important in industries, like I said, in healthcare, banking, supply chain, cybersecurity, and many others. All right, real world applications. So blockchain, oh, like healthcare, supply chain, government, finance, and education. Blockchain is already being used to make everyday systems safer, more transparent, and more efficient. Whether it's protecting patient records, tracking products, securing financial transactions, verifying college degrees, or maintaining government records, blockchain is able to help ensure that information is accurate, secure, and difficult to alter. I would also say that it's more like as more industries try to adopt this technology, it has the potential to improve trust, reduce fraud, and making sharing information faster and more reliable. Am I going too fast? I'm sorry.
Yeah, you're
Everything.
fine, Kel.
Okay, I'm sorry. And here we have like resources that we're able to use to get to learn more about blockchain. So for anyone that is interested in learning about blockchain, we have free and accessible resources available, like platforms like we have edX that offers university level courses that teach blockchain's fundamentals, smart contracts, and real world applications. But if you're interested on hands-on learning, GitHub is a great place to explore open source blockchain projects where you're able to view real code and even contribute as your skills grow. Like I would also encourage students to try free educational videos on YouTube channels like Free Code Camp and IBM Technology. It's easy to break down into understandable lessons. But the great thing about these resources is that you don't have to be a computer science major to get started. Like I'm not a computer science major, but it's easy for me to learn on these platforms. And anyone with the curiosity and the willingness to learn can begin building their knowledge of blockchain. All right. So as I'm an intern at MSCC, um, I'm just going to share what my project is because I know I don't have a lot of time. But for my project, I was able to use AI to predict heart disease risk by analyzing patient data, such as age, cholesterol, blood pressure, and heart rate to determine whether someone is at low or high risk. But as I'm coding right now, I'm just getting started. I'm able to like clean data sets, prepare for information learning. Machine learning. I'm sorry. Um, have it be able to identify patterns in the data and evaluate performance metrics like accuracy, precision, and ROC AUC to measure how well it predicts heart disease risk. And here's my last slide, closing my takeaway. So blockchain is more than cryptocurrency. Is it a secure way to store and share information that builds trust through transparency and verification across many computers? It is already used in healthcare, finance, education, government, and supply chains to improve security and accuracy. The main takeaway is that blockchain is about how we verify, share, and trust information. And the best way to understand it is by learning basics and experimenting with it. Thank you.
Thank you, Kelvin.
How do I stop sharing?
Let's see.
Anyone have any questions about it?
We'll take those after everyone's through, Kelvin.
Okay, thank you. I'm sorry.
No worries. There you go. All right, David.
Hey, thank you, and thank you for that very informative session, Calvin.
Thank you for having me again.
Okay, we're going to switch over to a little bit of AI resources here. Of course, I've introduced myself. I'm David Lockett. I serve as a co-PI at the School of Applied Computational Sciences. I also serve as the NASA Merit co-investigator and was recently awarded the HBCU Founders Initiative Pre-Accelerator Award. So today I'm going to bring you something a little bit different. I'm going to share with you the Artificial Intelligence Virtual Organization. I'm going to give you a quick overview and why this matters for researchers, why it matters for educators and institutions to engage with the national AI ecosystem. AVO, which is the NSF AI Institute's virtual organization, is the nexus for 29 national AI research institutes. It's a very large and distributed network that serves as a front door for AI collaboration, visibility, and access to a variety of AI resources. Uh, so what AVO organizes? So AVO organizes is a list of AI centers, and it's a hub that advances AI research, workforce development, and the next generation of researchers and practitioners. Collectively, these institutes connect more than 500 funded and collaborative institutions and organizations that span everything from agriculture to material discovery, cybersecurity, human-centered AI collaboration, and AI augmented learning. The lead agency is the National Science Foundation, and it's a very visible front for AI resources and pathways to better understand and integrate AI into your institution of higher education. Uh, AVO has a very unique education portal, and that education portal brings together 20 different partners that bring in journals, curated journals, resources from various funding partners, highlighted professional development, fellowships, internships, and a wide variety of NSF AI funded modules to help educators and resources kind of not only advance computing resources, but AI expertise, AI educational resources. It's a very, very unique um, collaborative that is available you know, bolster your AI infrastructure at your university. One of those features is the NAIR. I'm sure we're familiar with NAIR, which is the National AI Research Resource. This expands equitable AI resources across the United States. It provides a wide variety of access to computing, to data, to models, and tools for all. It also supports AI research, workforce development, and innovation across the ecosystem. Of course, HBCUs, MSIs, and other institutions are also highlighted throughout NAIR and CS Access. Uh, just wanted to thank you, as I know our time is very limited on this. Uh, AVO's mission is to bring new, high-quality AI learning resources to connect the network and provide kind of a broad contribution across the 29 different platforms and partners. I'll share with you the main screen as well, and we'll drop the link to join that as well. That's aiinstitutes.org, so you can have access to these various resources. Uh, you can also, connect, look at the portal, and translate these resources to your institution. Thank you.
Great. Thank you, David. Appreciate both you and Kelvin.
Definitely.
All right. For our next panelist, will be presenting is Rick McMullen. And Rick, if you'd like to introduce yourself and your emerging technology.
Sure, yes. Okay. My name is Rick, and I am going to try to pull off a technological feat here by sharing my screen. All right, so today I'd like to just mention a couple of emerging technologies. One is not so much emerging, except that it's more of a way of thinking about things, and that's hybrid computing. And the other one is neuromorphic computing. Uh, I'm currently working with Research Advisors Group. It's an organization that helps smaller institutions build their research capabilities and infrastructure. I've spent most of my life doing high performance computing and scientific computing. So that's kind of where I'm coming from here on hybrid computing. So just to set the stage a little bit, the research computing landscape is both relatively stable in one sense and very dynamic in another. The stability is that as our knowledge increases, the complexity of the problems that we have to deal with also increases. And at some point, you get this sort of intellectual or knowledge phase change where you go from knowing something to knowing something else that is new. So we have two general areas here that we want to consider. The first is hypothesis testing by model. So we have things like modeling and simulation. We have issues of scaling up, both in the sort of size of the model in its simulated phase space, and the scaling down of the model to smaller and smaller time increments. So the model complexity is a real issue where we want to improve our understanding of an hypothesis by adding more different physicses and higher resolution at the same point in phase space. So that's sort of the traditional mod sim approach to things, and I could say something about systems view and things like that, but it's all of a piece. The second major area that we need to consider is hypothesis construction. So traditionally, for I don't know how many hundreds of years, hypothesis construction has been through inference of observation. And now it's basically the same, except that we can collect with sensors and simulations and other kinds of data generating things. We can collect a lot more data. So if we sort of take that as an advantage rather than a problem, we can look ahead and say, well, what if we just threw everything into a pot and let something else figure out what was significant? So that's kind of an area where assistance from neural network, AI kinds of things, and machine learning advances are going to significantly help. So a researcher who's on these frontier areas needs to kind of integrate these two things, hypothesis testing and backing up when an hypothesis seems to have problems, back to construction through inference. So the first thing I want to talk about is shifting gears radically here, is to talk a little bit about how we can approach both of these using available technologies. So hybrid computing is different things to different people. To companies that sell machine time, it means combining your stuff you have on site with what they can sell you as a cloud resource. And in point of fact, this has some advantages in the sense that if you want to try something out, or if your institution can't really afford to give you full kit, you can have that and use it without a long-term commitment. The other definition of hybrid computing that I'm more interested in is the combination of several specialized computing capabilities within a single complex that you own. Things like, okay, multi-core conventional CPUs plus GPUs or TPUs or whatever, other specialized hardware that has specialized focused capabilities that can help you solve specific problems.
Rick, we're running out a little bit of time here.
Okay, I'm going to move on then real quick. So the other area I want to talk about briefly is challenge of neuromorphic computing. And the question there is, how can we make hardware that has some neuron-like capabilities that allow us to reduce the power we need, provide massive parallelism, et cetera. So for neuromorphic computing, here are some of the current challenges. It's hard. There are different technologies. They require specialized fabrication capabilities, but the potential for disruption is rather high as these pieces of hardware excel at things like machine learning tasks and can be applied basically across any discipline that requires um, high performance computing for processing large amounts of data. So I'll leave it there for now and pass it back to you.
Thank you, Rick.
Sure. Unshare.
Our next panelist, Patrick Clemens. Patrick?
Thanks, Michael. Hey, all, I'm Patrick Clemens. I'm at the University of Vermont. My role there is Director of Research Computing for Large Research Initiatives. And what that means is that I work with large groups of researchers, most usually interdisciplinary projects, and help them utilize high performance computing and advanced computing technologies in their larger center level grants. So I typically work with, like dozens of researchers on a project, and help them, run models on HPC, set up their cyber infrastructure for the, duration of the grant, things like that. So that's kind of where my perspective is. It's largely research focused, research facing, but we do a lot of software as well, and I do some of the system setup as well with working with our ETS. So the technology that I was going to talk about a little bit today, I don't have any slides. I just had a couple of points to make. Was AI, and I don't know if AI is still emerging technology. It seems like it's already here. It seems like a lot of it has emerged, but I think these pieces are still emerging. I kind of wanted to make a couple points on this to kind of seed discussion in a bit. So, I've been around AI for a long time. My research in electrical engineering or for dissertation was in speech technology. We called that AI back in the day. We didn't have deep learning neural nets and LLMs. And I think if you go to an AI conference today, you'll still see a lot of those older technology. Well, not older technologies, but updated technologies. You don't see a lot of LLMs still in AI research conferences. You see a lot of deep learning, image recognition, all this, and all those kinds of deep learning algorithms that still use the same algorithmic improvement that gave us LLMs, but we're using it for video analysis, time series analysis, and all these other kind of data-driven research ideas. So, when we talk about AI, the first point I want to make is that it's not just LLMs. AI encompasses this large realm of things that researchers care about. And so a lot of the AI stuff that I've been doing is around 2D geographic information systems, image analysis, tracking, tracking land use across time. We have an AI system that does human decision making. We have an agent-based model that does that tracks agents over time, and each agent is embedded with a deep learning neural net that helps them make decisions over time. We do a lot of time series analysis with hydrology, where we try to track the height and flow of rivers using deep learning algorithms. So first point, AI is not just LLMs. There's a lot of stuff wrapped up in that use very similar algorithms and have a great use for HPC. The second point I want to make that I think AI is changing is our researchers' use of it. So AI isn't just like an algorithmic tool. It's not just a research tool. It also helps us do the research and actually do coding. And one thing that struck me earlier this week when we did the intake interviews is a number of researchers were pressed about well, what kind of code did you use? What Python packages do you use? And their answer was, well, I just use ChatGPT. And so I see AI really changing how us facilitators have to ask questions and how we facilitate, because no longer do our programmers and our grad students necessarily write the code themselves. They're prompting ChatGPT to write it, and their understanding of that code is different. I'm not going to say less, I'm going to say different, right? And so I think the more we use AI as a tool, the more that knowledge is passed on, the more that the creation of these of data and knowledge is passed on to these algorithmic tools, and less is being done by the researchers. And I think that really changes the way that we have to think about how we interact with them and the questions we ask and the tools that we ourselves use. So that's my second point is that AI is really changing how research is done. And that means it has to change how we facilitate that research as well. And the last point that I want to make is kind of around hardware. And this is kind of more about emerging technologies generally, but I think AI has really changed the hardware landscape. It used to be that when we had emerging technologies, I feel like there were algorithmic or software improvements and they were pretty accessible to most folks. But now if you want to use AI and large language models, you need money to pay to work on a token generation large data center that runs through Claude or Morphic or OpenAI or any of those big providers. Or you need to have a huge HPC with a ton of GPUs at your home institution that can run it yourself, and that requires all kinds of other technology and expertise. And as opposed to another change too, as opposed to like the CPU revolution where we had options to buy our CPUs from Intel, AMD, RISC manufacturers. Today, I mean, there are other people that make GPU processors, but we all know there's one company that we all want the GPU process to come from. And we're all sitting around waiting for our H100s to arrive and trying to figure out how we can afford our next batch of H100s. And a lot of this because they also built the software stack, right? CUDA underlies so much of this AI research that we're doing, and that's NVIDIA. And so I think this has really created an interesting and unfortunate economic bottleneck in this in AI research that is really affecting all of us in terms of just getting the equipment on our campuses. We're getting our researchers able to access this technology through National Supercomputing Center. So my third point is hardware is such a critical component of this AI. And that's a little bit different, I think, than some of these other emerging technologies where you can get a couple ASICs or neural processors and play around with it. But to do AI now, you need dozens of these things, and they're just not available, and it's becoming a real bottleneck. So those are my thoughts on AI for discussion, and I'm interested to hear your thoughts as well.
Thank you, Patrick. Appreciate it. Our next panelist is Jude. And Jude, I apologize if I am not saying your last name correct. I'm going to say Akoli, Jude Akoli.
Can you hear me?
Yeah.
Can you hear me?
Yes.
Yeah, it's a little low, but we can hear you.
Yeah, sorry. I was in transit, so I tried to make it. So same with Patrick. I want to talk about AI as an emerging technology, but this time around, I am more focused on AI use in higher, especially in teaching and student learning. I should introduce myself. My name is Jude Okoli, and I am an assistant professor of chemical engineering at Bucknell University in Pennsylvania. So I don't know if you can still hear me because I have a very, very bad internet connection
Yeah,
here.
you're breaking up a little bit. Maybe if you turn your camera off, that'll help.
Oh, okay. Okay, great. I'm gonna try that. Okay. Is this better now?
It seems like it. Let's go with it.
Completely apologize. Yeah. So if you can hear me, like I said, my name is Jude Okoli. I am an assistant professor of chemical engineering at Bucknell University. So same with Patrick. I'll be talking about AI as an emerging technology, but my focus is more on AI in teaching and student learning. And apologies, I didn't have a slide. So I wanted to start with what areas I've noticed we have used AI in teaching and student learning. And one area that I wanted to talk about is in assessment. So assessment is a very important part of learning. I mean, it's a way where we can assess a student understanding what we're teaching them, or a way where we can evaluate what level a student is at. One thing I noticed recently is that the level of student that comes to office hours has decreased a lot. And that's because students would normally naturally just prefer to, instead of coming to office hours to ask professor questions, they could just ask ChatGPT questions for answer because they're more comfortable with that. They could send a prompt. So we've started looking at, okay, how do we broadly encourage students to not over rely on GPT or on AI, and at the same time, how do we let them understand that these tools are available to help you understand better while also navigating the challenges of students not understanding what we're teaching in class. So we came up with an app. The app is called JQuiz. And what the app does is that we tell students to register. We designed the app using AI to design it. So what the app does is we give it a prompt and say, okay, if we're teaching a particular class, this is the learning objective of the class. Generate questions to test student knowledge. And if it generates the question, it generates like 200 random questions. So our students will go and take it as a multiple choice question. So when students take that questions, the app evaluates student level of understanding of that question. It also gives them like personalized feedback. So those feedback it sends to the student. He also sends it to us. We as instructors, we take those feedback, we read it, and then we can schedule a meeting with the student. So, hey, you took this test. This is what happened. These are areas you need to improve. So I piloted this app in a differential equation class. It's a math class. And so it's more of differential equations. Student from sciences and engineering took the class. So what I did was, why I designed the app in such a way that each week students will go and then they would, based on what we covered in class, they will go to the app and answer some questions. And once he answers the question, the app will provide feedback to me. So it's also a way that it tells the student, okay, this is the level you are in a topic. You might need to speak to a professor or you might need to learn more. The other reason why this is very important is because as students progress, it tell me this is an average, this is the highest student. It kind of gives me the class distribution. So that way I can go and then see, okay, you are at the bottom of the class. I can meet with you personally and say, do you want to come to talk about this? Do you want to improve on this? So it's an AI-based app, and it's really been very, very helpful. That's in terms of just understanding students. The other area I really, really want to talk about is in terms of um, assessment. Like I mentioned before, in terms of assessing them. So what I have done is I also could give a prompt and say, okay, we've covered this based on this learning objective, set a set of questions for me. But I review the questions, and then after I review the questions, I'm able to also say, okay, set the rubrics for this. So if you set the rubrics for me, based on the rubrics, I'll give to the student. And it's always been very, very helpful also in doing that. But one area that I really, really also want to talk about is content delivery and creation. So these days, I mean, as I've been a professor for a while, and I found myself spending a lot of time creating content uh, and then understanding it before teaching to the student. So I believe with AI, it helps remove the bottleneck in creating content. That way, teaching becomes more iterative, adaptive, and system driven. So I can spend more time understanding the student. I can spend more time looking for ways to engage them in active learning instead of spending more time designing and creating style. So that has really, really been very, very helpful. But regardless, I know I've seen so many people using AI. The key question is AI is there to stay. It's just a way to help understand how we can encourage our students to use it ethically, and also how we can use it to kind of make our teaching more productive, faster, and help our students learn better. So I'll stop here.
Great. Thank you, Jude. Appreciate it. For our last but not least panelist, we have Fanny Milanova. Fanny, take it away.
Okay, thank you so much. Let me see if I can share. I will be very brief, actually. Can you see the slide?
You can see it. I can see it.
Okay. Okay. So my name is Mario Fana Milanova. I'm a professor in computer science in University of Arkansas Little Rock, and also I'm a certified NVIDIA instructor from 2018. I recommend and I participate many times with Henry in virtual and in-person events. I suggest everybody actually to get certified, to become a certified instructor and of NVIDIA and help faculty and students. So, but what I have right now, I'm not going to present everything, is to talk about quantum computing. And I have also very brief messages. One of my main messages is that right now we need to do a little bit more multidisciplinary work. I always appreciate people working multidisciplinary areas. And this good example, for example, the Nobel Prize from 2024 that Hopfield and Hinton. Hopfield is physician and Hinton computer scientist. But both of them, they got a prize for neural networks. Okay, Hopfield and Boltzmann machine. So this Hopfield neural network actually is a base of is associative memory. And I have my whole study actually was on the base of different neural networks. So I'm showing how actually these two disciplines are merged together right now in quantum computing. Currently, we have actually workshop. I'm not going to present everything from my slides, but just some slides because currently we're doing the workshop and with teachers from IBM or from people from MIT and stuff on quantum computing. So quantum computing become very popular, but because instead of having 0 and 1, you have also probability. If you imagine the coin, flipping the coin, when the coin is not in the stable position, we have a probability to be between 0 and 1, okay? Some probability. This is what we have also in Hopfield network. Hopfield network association, for example, I give example of smell. So if you smell some food, in your memory, you can differentiate maybe it's potato, maybe it's some meat, maybe it's something different. So your memory is trying to become to the stable state. So actually, Hopfield integrate. He actually, if you listen the original speech when he gave in receiving Nobel Prize in 24, he mentioned that he got the idea from neuroscience. So the idea is coming, he's physician, but he got the idea from neuroscience, and he applied the Ising model that you are trying to figure out stable system with low energy. So the energy in the physics system is different from energy of the model, but the concept is the same. So my first message is you need to work multidisciplinary approach. I did here the comparison, of course, between quantum machine learning and neural networks for people that are computer science and they understand neural networks. It's very easy for them to understand quantum computing. So I'm not going to show you all of this, but what I want to say, the second big message that I have is people need to understand that the hidden space is actually very powerful thing. So everything come, even the new generative AI. I have courses in generative AI and agentic AI that we offer. All of this come because of the existence of this hidden space, and superposition in quantum computing is also one example of hidden space. Okay. So this is kind of history of how this hidden space is implemented in autoencoder, is implemented in a diffusion model in agentic AI. Okay, so what we offer to our students, to faculty, and to researchers, we actually have a grant from NVIDIA, not for quantum computing. It's agentic AI and edge devices, but we're moving also to use CUDA-Q, because NVIDIA is not working on hardware, quantum computing hardware, but is offering a lot of simulation of quantum computing. So Isaac calibration, Isaac decoding, and yes, this is what I always like to show this hidden space, is a Plato's allegory. And this concept, like I say, is like implemented right now in large language models, in agentic AI, in generative AI, and in quantum. This is that is the story is that people are living in the cave, and they see only the shadows from environment outside. So they think that this 0 and 1, they think that this is only the possible solutions, but it's not true. We have many possibility, many probability between 0 and 1, and this is the hidden space. Okay, so the software that we currently are using and is here is Penny Lane. Actually, we have a speaker right now from Canada that is original creators of Penny Lane. We use CUDA-Q, Cascade, and there is a MATLAB quantum computing too. Okay, so this is what I want to just briefly mention now. Thank you.
Wonderful. Thank you. Thank you all. So we are ready to start taking questions. And Henry, one question I forgot to ask before we start taking questions, will people be able to use their microphones to ask, or will they need to submit chats?
Either and both. I would encourage people to do whichever they're more comfortable with.
All right, thank you. All right, so let's start taking questions for our panelists. Who would like to be first?
I'll jump in.
Great.
So for the format, I mean, are we present? Do I just kind of answer what's there? I'm looking Q&A now.
Well, yeah, we're just kind of letting the everybody out there who's been listening ask questions of each of you panelists on anything that might have caught them. Sorry, I should have been a little more clear on that, David. Anyone on the audio or chat? Use chat if you're shy.
Hey, I've got a question. Since the audience is primarily people who are researcher facing, I mean, the question is in emerging technologies is assessing the potential, and maybe if there is a camel's nose under the edge of the tent, do you go to extremes to try to support that person's interest, or do you just let them do their own thing? And conversely, are you on the lookout for situations like that where you can learn from those interactions and maybe add it to your support organization, whatever that capability is? So it's more about, how do people support emerging technologies?
That's a good question. Anybody focused on that right now or struggling with that or strategizing with that at the moment out there?
Yeah. I'll provide some thoughts. So emerging technologies tend to be, a pretty big leap in supporting and implementing, right? Like that's the nature of emerging technologies. They're emerging because the ecosystem of tools to use them is usually underdeveloped, right? That's why they're emerging. So I think we're in that case with a lot of AI stuff, right? Like if you want to go out there and learn about AI, there's definitely a lot of tools, but it's not something that you can like, download and start using tomorrow. And same with quantum and all, and neural processing. It requires some investment. And as facilitators, like we can't be experts in all these things. And so I do think that there's a big resource question here, right? So if I'm being funded 50% on a grant and they want me to like learn a new technology to support them, I'm going to learn it because they're paying 50% of my salary. If they're paying 5% of my time and they want me to stand up an LLM on the HPC for them, well, that's a whole nother ball of wax, and I'm going to see if we can get some other, way around it. So I do think, in the end, resources play a big role in the answer to this question. Like, do I have the time and the resources to dig into this and help support my researchers and this emerging technology? And if I don't, then what are the shortcuts that we can do, or what are other alternatives with things that are easier to like use, learn, or support? The other thing I will say on this too, once you stand up a service and support it, you kind of have to keep doing it. And so if you get like a chunk of money to stand something up and that money goes away, I mean, a lot of the expectation is that the service is going to continue to exist, but like there's no resource to support it. So I think too, when you think about, standing up a new technology, do you have an exit strategy or a sustainability plan for like that new thing that you're going to stand up? I cannot tell you the number of websites that I've made over my 14 years that have withered on the vine. And that's fine. Like that's kind of part of research, right? Like things come and go. But you have to kind of go into that knowing that like either A, it's fine if this thing withers and goes away, or B, I have to figure out a way to make this thing continue once those resources go away.
We're getting a couple of good questions here, and into exactly kind of what you were saying, Patrick. We have a question from Sean Daughtry to the whole panel: is for any type of emerging technology, what is the way to develop the next generation of IT experience, sysadmins, research support? So he says, I'm thinking, how do you develop those skills for things like the latest NVIDIA Mellanox NIC, InfiniBand switches? It's pretty costly to buy something for a home lab. Is there a national coordinated effort? And Patrick or David, I think you were hitting a bit on that earlier, possibly, unless I'm mistaken.
If you allow me, I can add that there are so many open sources right now. So you can use open sources. So they are available GitHub, and yeah, so it's there are so many. Actually, yes, David mentioned and Patrick resources from NSF, cloud services that you can use it. So probably David will add a little bit more.
David?
Yeah, I was going to say, there's a variety of, not only open source resources, but, expansive resources. I know a lot of the resources that we're using for AVO, we're using those with undergrads, we're using those with master's students, we're using those with PhD students, and they're used in a wide variety of modalities. Our parent organization is the medical college. So we're using them in a medical college, we're using them in, a data science capacity, in a biomedical data science capacity. So, when you look at those resources, you not only want to make them, introspective, current and up to date, you want to make them expansive and versatile so they can be used in kind of any setting, any capacity, from, beginners all the way to, professionals, whether it's undergrad students to PhD students. So, take advantage of those resources, whether it's Nair, whether it's AVO, whether it's CS Access, and make sure they're a good fit for your project.
Thank you. Kelvin, we've got a question for you. For let's see, is blockchain fitting into your summer research project, which I believe you said involves AI deep learning? They're just wondering in general how and whether blockchain and AI relate to each other. You'd like to learn more about each of these. Perhaps you already talked about this.
Okay, so yes, I am. It does relate to my summer project, but I really haven't gotten to the deep learning part. It's really the machine learning and the LLMs. I mean LLM. Um, but specifically, is to like help predict heart disease. But the blockchain isn't like used to make the predictions itself. It's more to securely store and share like the patient data as it's protecting its privacy. Um, but it also would help ensure the data is secure, that it's trustworthy, and that let me see that it's like it makes healthcare systems like both smarter and secure, if that makes sense. I'm sorry.
I'd like to add a question to that, Kelvin. As you're listening to kind of some of the other panelists here and the technologies they're talking about, in relates to blockchain and the research you've been doing on blockchain. And specifically, my question is with quantum computing and the security concerns of its ability to crack, a secure environment. Have you thought about that in any way, shape, or form with some of these technologies and the potential threat with blockchain, or is blockchain kind of an impervious solution, do you think?
Um, let me get a few seconds to think on that real quick. I'm sorry. Um, are you able to repeat that one more time? I'm sorry.
Yeah, like with quantum computing,
Mhm.
and one of the concerns about quantum computing is it's going to pose a threat to secure systems, secure environments, right? Because it's just going to go at such an incredible speed and calculation. And I'm probably oversimplifying here, but anybody can answer this as well. But I just wondered if you had heard or read or seen anything during your research on concerns with blockchain and the future of computing and specifically quantum computing.
Well, I haven't done much research on quantum computing, but like the cyber, are you saying like the cybersecurity part of it?
Yeah.
Um, Well, I'm thinking that the cybersecurity part that it's supposed to, like I said, I'm a health science major, so I'm like just doing research and I'm just getting the understanding of it. But as I'm figuring out that blockchain is just like to protect like people's data and help around it. It's if that makes sense. I'm sorry.
Yes, absolutely.
Hey, Michael, can I go back and answer Sean's question a little bit better?
Yes.
So, Sean, I think this is a really interesting question, and it's a really big problem too. I'll tell you what University of Vermont did. We hired people from Big R1s that had experience with those technologies and brought them to Vermont and kind of stole them. But I know that that's not really the answer you're looking for. I there are efforts. So the one thing that I thought of when you said this about coordinated effort, every year at SC, they start, I don't know how many weeks early they show up there, but they show up there early and build a network from scratch, right? And Cisco shows up with their new stuff, NVIDIA and Mellanox show up with their new stuff. And every year, SC builds like a full, routed network from scratch with all the newest stuff and beta firmware and all that good stuff. And it usually gets it working. So, and you can sign up to be part of that. So there are like cool things like that, I think. And I will say that like the big supercomputing centers, I think do serve as a bit of a training ground for a lot of these technologies, right? They can afford some of these, newer pieces of equipment. Um, they have funding to send their folks to training at these places to learn these things, and then things kind of filter down from there. But what you're asking for is, is there like a coordinated way for like me at a mid-range, to small institution to like go and learn this stuff, not without paying thousands of dollars from the manufacturer to attend their training courses. Not that I'm aware of. I think what we've done is just kind of filter down from the big players and grab the people when we can. That's been our strategy.
Can
Thanks,
I chime
Pat.
in on my own question for 20 seconds? Is that okay?
Absolutely.
Yeah, no, I was just going to say thank you. That's exactly what I was thinking. There's digital twins like NVIDIA Air, but of course that doesn't include the entire ecosystem. And at some point, it would be nice if there could be a physical twin, so someone could actually, do an InfiniBand switch somewhere and then erase it later on for someone else to remotely access and experiment with things like that. So thank you very much.
Yeah.
All right. Anybody else have any more questions? I sure do. Here we got one, Alexander. On neuromorphic computing, would like to hear a bit more on what type of hardware projects are out there.
That is a really good question. So I've been interested in this for a number of years, and it's in terms of analogies, it's sort of like where AI was in the 1950s. Lots of potential, no real way to realize what's going on, but it's over the past decade, 15 years, there have been maybe half a dozen major productions from Intel, IBM, Tsinghua University jumped in at some point, and these are experimental systems. The main point is that they are not, the actual part is dynamic in the sense that the core model is a spiking neural network. So you have to create something that can reproduce that functionality. So there have been some interesting technology developments, particularly memristors have been resurrected from the junk heap of history and turned into neuromorphic devices, and also some magneto-restrictive devices have been used as well. But the issue is that this is something, the core driving thing is, can we make something ourselves that is not organic, that imitates organic neural processing? So I think at this point, there have been a number of different experiments. It's been mostly based on, traditional fabrication techniques for electronics. But the real thing is there's going to come a breakthrough in materials where somebody realizes that they can create something that does what you can do with traditional electronic manufacturing components, and do it in a way that's a little easier to work with. So I guess what I would say about this is that you can go out now and scrounge up something that is interesting and work with it. And I think this is really to the point where it's going to be directed by what's happening in different domains, particularly things like real-time signal processing and maybe as interfaces for quantum devices. But it's very emerging. It emerged for a while and then it kind of went down into the trough of whatever it is in the hype cycle. But it'll be back, and basically it's the idea that people are playing with these technologies or working with them and trying to make them do certain things, and eventually somebody will get something to work, and then you'll end up with something that computes in an interesting way without requiring massive amounts of energy. So I hope that answers part of your question. Um, you can find something from Intel if that's your level of comfort and go do stuff.
Great, thank you.
Sure.
Anyone else have any questions? Okay, here's one from Michael Stewart on quantum computing. What is the anticipated timeline and use cases? How will this be rolled out? Will universities develop on-prem solutions or relegated to enterprise cloud? How will it impact research and analysis? And how will it fit with existing AI infrastructure? Now that's a whole lot. That might be a whole nother session, huh?
Yeah, it's too
Great
much.
question.
Yeah. Okay. So, well, right now, from 0 to 5 years, we're working mostly in hybrid quantum classical AI and quantum simulation, mostly. Yes, the question is that not everybody can buy the soft hardware, and the hardware is still in the process of development. It's not actually for everybody. So I think that this 1 to 5 years, we have to work on simulation, quantum simulation. And there are tools that I already suggest. Open source Daniel Lane is very useful. CUDA-Q is very useful. So after that, we hope that, of course, there are big changes coming, like internet changed the communication, generative AI changed how people write and learn and using ChatGPT. This is how quantum will change the way that we're doing optimization. So optimization tasks are everywhere in the drug development, in the healthcare, in the financial service, in blockchain optimization, cryptography also will benefit from quantum. So, yeah, after 5, 10 years, I think that this will be very popular and broad participation of variety of scientists will use quantum computing. I don't know if I completely answer all the questions, but I just briefly explain. But for now, you can use the existing, yes. Like I said, there are many similarities between the neural networks and quantum computing. Also, people, I mean, that can they have a lot of resources to start simulating quantum computing and quantum machine learning, particularly. There are good books and courses, so they can step by step move to the quantum computing era.
Thank you. Anybody else would like to comment on that, on Michael's question? So we got another one here. From Joe Lavelle. What about parallelization of quantum computing? If price lowered, would it be possible? I hope I said parallelization. I can't say that fast 3 times, but
Well, this is the nature of quantum computing. Okay, so this is what why is faster than regular computing, because you have more possibility to search. For example, if you are using the search algorithms, you are doing in parallel this search. So there is a parallel processing included.
Yeah, I'm sure, Fanny, you can probably get a better answer to this, but to help Joe out a bit, like the nature of quantum computing is parallel. Like that's
Yes,
why it's so powerful.
exactly. This is what I'm saying. Yeah.
So your question kind of is not is kind of it doesn't really make complete sense because all quantum computing is parallelized.
Exactly.
So,
This is the main
yeah.
idea.
So the strength of the quantum, I think a better question might be, like, so the way that they expand the power of quantum computing is by adding qubits to the
Mhm.
processor system. So, we're at like, where are we at, Fanny? At like, a couple dozens of of qubits we can put in one system, like let's say like 64, 128. That's like kind of state of the art of currently where we're at. And as we get better with building these things, we'll be able to build a quantum computer with more qubits. And
Correct.
as those qubits get bigger, the parallelization gets bigger naturally. That's the nature of quantum computing. I hope that
Ex-
helps, Joe. As well.
Yes,
Exactly. This
that
is what
helps
they
a lot.
discuss right now, how many qubits, but this is very related with the task. Okay, whatever is your task, you need probably many qubits or you don't need many qubits for your task.
Is the limiting factor in quantum now hardware possibilities or price or both? Like you mentioned qubits. Is qubits a physical limitation or is it a money
Yes.
limitation? Okay. Yeah.
Yeah,
I have
I would say both. There's
uh,
physical limits to how many you can slam together because they start to interact, and it's expensive to build. So both.
yeah, I know it's expensive, that's for sure. Thank you. My understanding of quantum is very limited and in our center we have a guy that works on it and he's so far out there I can't keep up with him.
Well, I'm also not
It's a
expert,
lot.
so I'm new too in the quantum computing, but like I say, from machine learning, we moved to quantum machine learning. So quantum gradient descent is very popular to use. And this in parallel processing is really powerful. Even the people show me here the means in parallel. Of course, the clustering can be faster if you use quantum computing. So we were using it biology a little bit. The students like to use the libraries and don't exactly probably understand the whole theory, but we're trying to teach them also. So we're new in quantum computing too.
Yeah, the area at Purdue where I see the most growth in quantum is drug discovery. That seems to be
Yeah,
a hotbed of quantum.
thank you.
Will AI increase the speed at which we're able to have quantum computing as a reality? Will it participate in the speed of execution on that and the reality and day-to-day reality of it?
Patrick, do you want to answer?
Well,
Or-
so again, this is not like I'm not a huge expert in this, but I was reading a couple months ago, NVIDIA is making a play in quantum, as Fanny was talking about, in terms of doing simulations with Q to Q. But I feel there's also a play being made in that, once we have these quantum machines, they're not electron based, right? So they don't like you can't just like plug it in to the back of your HPC with an Ethernet cable and have it work, right? And there's a lot of processing that needs to happen to understand the answer that the quantum computer gives you.
Yeah.
And that processing of the quantum information, the quantum results, that is where AI is going to help us a lot. And as the quantum computers get bigger and bigger, the understanding the results from the quantum computer get more and more complex. And that is where NVIDIA sees their play as using their AI technologies to interpret those quantum results in a way that makes it easier for us to understand.
Yeah.
So does that kind of help answer your question, Michael?
Yeah, I can add to Patrick that actually the deep learning models help a lot
Yeah.
because they use 3D convolutional neural network, and they are using visual language model actually capture the state of the quantum processor and interpretate what is the state with this Ising state and do the error corrections. So this is implemented already for companies that are doing the hardware. So the area that AI and deep learning models achieve, they're helping a lot quantum computing right now.
We're about at our 4-minute mark. Does anybody have any other questions? See, you might have one here. Let me see. I'll throw out another one if nobody minds. In regards to quantum computing, neural networks, as we're trying to replicate how the brain works, I'm curious if the research going into that, because I was thinking about Kelvin being in health and science, if all that we're learning about the brain and we're bringing into these computing models will help with actual helping with a more healthy brain, Alzheimer's or memory loss or all sorts of those things. I was curious.
Very good
Yeah,
question.
I'll throw out this. I think yes, the answer is yes, and it has something to do with in current state of quantum computing, the need to deal with noise and the effect of noise on the system as a whole. And so, brain disorders are caused by communications problems, and those manifest as noise. So, as we learn, I mean, there's a whole body of stuff about this. I mean, this is not new, but it is some of the techniques that we learn in making quantum computing devices may be useful in understanding how to control what goes on in wetware and human systems in terms of seeing it, understanding it, and eventually controlling it.
That seems to make sense and better understanding. It's kind of like an offshoot because we're learning about the brain so we can make these improve these systems, but with another outcome of actually being able to solve some of these issues that in health science with brain research and whatnot. So, any other questions, even from our panelists to the other panelists? We've got time for one more, I think.
So I'll ask a quick question. Like, what are folks doing about accessibility, right? The big key for all these technologies is that they're rare and expensive. And so I'd be curious to know, like, with each of the technology we talked about, like how are we making them accessible to the most amount of people, or is that just something that's going to have to come down the road?
Yes, is the technology moving so fast that accessibility can't keep up with it? Is that
Yeah, and I mean that might be the answer. It's not the best answer, but I think it tends to happen with emerging technologies. They're rare and expensive.
And I agree. In a lot of our workshops now, they have a specific component on accessibility. They're receiving feedback. They're working hands-on during these labs and these modules, to get the feedback and get the ideas to, add that accessibility components. That's a very good question.
excellent? Well, I think we have come to the end here of our time. I'd like to thank each of the panelists and everybody who's joined us. Henry, I know this was being recorded. Will everybody get a link to this or?
Absolutely. We post all of these videos on our YouTube channel, and in fact, this is the final one that's going to get posted, and that should be later today.
Excellent, excellent. Well, thank you, Henry, and thanks to our panelist, Kelvin. Welcome. We're glad you're here. We appreciate your presentation on blockchain.
Yeah, it's great.
Thank you.
And everybody that has attended. Have a wonderful day and a wonderful weekend.
And let's give our panel a round of virtual applause.
Thank you so much. Thank
Thank
you.
you.
Thank you.
And I'm going to stop the recording.